Okay, so in the standard forms for these functions, there's actually 4 letters. We're going to talk about the 2 easier letters today, so we're going to kind of build these as we go. But for today, what I want to talk about is this. For the standard form, or sorry, the first sine one, I guess I'll do the sine one first, since that's what I drew first in the parent function. So the 2 letters that I want to talk about today are the letters A and the letter E. Okay, so both of these letters, if those are numbers, are going to have an effect on the function. What you'll notice is in the parent function, both of those letters were a 1, which is why I did not write them in the parent functions. But if you change those from a 1 to something else, those will affect the graph just a little bit. So let's start out with the letter A, because that one's super easy. So the letter A stands for amplitude. Okay, and if you've done anything in physics with waves before, you probably have heard of the word amplitude. Amplitude is the distance from equilibrium. And if you're talking about a wave, equilibrium is the middle of the graph, which as long as it's not shifted at all, the middle of the graph is going to be 0. Now we will eventually shift some of these up and down, but for us, for right now, it's the distance from equilibrium, or the distance from the middle. Okay. And one other little note, what you'll notice is that the height of the graph is always going to be equal to 2 times the amplitude. Now sometimes the amplitude will be listed as a negative number, so we're going to go ahead and put an absolute value here because the height must be a positive number. But if the amplitude is the distance from the middle in both directions added together, that's going to give me the distance from the top to the bottom of the graph. Therefore, that will be the height. So just to give you a quick example of this, let's say we had something like y equals, we'll go negative 365 times the sine of x. Okay, so we would say, okay, in this case, A is negative 365. Okay, I usually give amplitude, since amplitude itself is also a distance, I usually just say it's a positive number. So the amplitude of this graph is 365, but because there's a negative in front here, that is going to change the graph a little bit. If you remember from earlier studies of functions, a negative takes something and flips across the x-axis. Okay, so if we go back and we think about a sine curve here, okay, here's our parent sine function. What you'll notice is the function started out in the middle and it started out going up. Okay, well, if we flip this across the x-axis, okay, instead of starting going up, our graph is going to start by going down. Okay. Another thing that I want you to notice here in the parent function is if we ignore these spots in the middle, it's almost as if the graph is split into 4 separate pieces. It's got a beginning piece, it's got this piece right here in the middle, or in 1/4 of the graph. It's got another piece in the middle, it's got another piece here, and then it's got another piece here. Okay. So what I'm going to actually do is, if the length of one period of the parent function was 2 pi, or 1 trip around the circle, because we didn't change the length of the period, and we'll get into what that means in just a moment, the length of the period doesn't change on this one either. So we're starting at 0, and once again we're going to end at 2 pi. And if we're splitting this up, okay, the length of the period also did not change at all. So each little piece here is not going to change at all either. So halfway between 0 and 2 pi is pi. This is going to be pi over 2. This is going to be 3 pi over 2. And the only thing that changes when we change that amplitude is the top number here and the bottom number, instead of being 1 and negative 1, now they're going to be 365 and negative 365. Okay? So if we're going to go ahead and graph this, this is a sine curve, and some of the little patterns that you'll see, sine starts in the middle and it always ends in the same spot. In this case, because this is a negative sine curve, instead of starting in the middle and going up, it's going to start in the middle and it's going to go down, back to the middle, up to the top, and it's going to finish in the middle again when we're done. And you'll get used to these patterns as you try some of these. But when we're done, we'll go ahead and we'll draw in our function. Okay, so the only thing that this number on the front changes, this amplitude, is it changes how high and how low our graph goes. Okay. All right. Next up, let's talk about what that letter B does. Okay. I'm going to give you a little equation here, and then we'll talk about what this means. So the period of the graph. Okay, and the period of the graph is just one full cycle. So we graphed one full cycle in the parent function, and in the example that I just did with amplitude, I graphed one full period as well. The period is always equal to 2 pi divided by whatever the b value is for the function. Okay, so what we're going to do is we're going to take 2 pi every time, and we'll identify what b is. From there, we're going to go ahead and we're going to use that to help graph our function. So give me one moment here, and I want to put a little note here. What we're going to do once we find the length of the period is we're going to split the period into 4 equal parts. Okay, one of the reasons why we're doing that is because, like, if you look at this example that I just did right here, there were 4 equal parts here, 1, 2, 3, 4, and for the y value for each one of those parts, it's either in the middle or the top or bottom each time. We don't have to worry about any of these points in the middle between those. The graph is going to touch those points once we connect them, but by splitting it into 4 equal parts, it gives us an idea of where we need to put each one of these points. Okay, so to give you an example of that, let's try this. Let's go y equals the cosine of pi over 2 times x. Now eventually what we'll do is we will include examples that have both an amplitude change and a period change, but for this one, just to try and show you individualized, let's just talk about the period. So the b value out front here is pi over 2. Okay, so a lot of times what you'll see me write examples on these is the period is equal to 2 pi divided by the b value, which is pi over 2. Okay, when I divide by a fraction, that's the same as multiplying by the reciprocal, so this is 2 over pi. The pi's cancel out, so the length of one period here is 4. Okay, so let's start setting up our graph. So the amplitude of this one is 1, because there's an invisible 1 out front here. So I'm going to put my top value is 1, my bottom value is -1. But now instead of my period going from 0 to 2 pi, because the length of the period this time is only 4, I'm going to start at 0 and I'm going to end at 4. Okay? Now, if I'm splitting this into 4 equal parts, and by the way, for some reason people struggle with this, I haven't quite figured out why yet, but if you're trying to split this into 4 equal parts, put a piece in the middle, and then put a piece in the middle of both of those, and now you have 1, 2, 3, 4 equal parts. Okay? And if this is 4 equal parts, we're going from 0 to 4. So I usually put a little bit of math here on the bottom. Each piece, which sometimes I'll abbreviate EP. Okay, this is not like something you'll see in a textbook, but this will just help us in terms of graphing. If the length of the period is 4 and we're cutting it into 4 equal pieces, that means we need to multiply the total length by 1/4 to figure out each piece. So each piece is going to have a length of 1 here, which means starting at 0 I can just count by 1s until I meet up with 4. So 1, 2, 3. And then I can go ahead and I can draw in my points. Now this is a cosine curve, which means we're going to start, and it's positive, so just like our parent function for cosine, we're going to start at the top, and the first place we're going to go is down, and then we'll meet back up at the top again when we are done. So we're going to go up here, middle, bottom, back to the middle, and up to the top, and we'll draw in our curve here when we're finished. Okay? So there is the graph of this particular function. Okay. In these last couple minutes, what I'm going to do is just give you 2 little examples. I kind of show you one example of a sine curve and one example of a cosine curve where we have both an amplitude and a period change mixed in. So for our first example, let's try this. Y equals -5 times the sine 12 pi times x. Okay. On one like this, you can go ahead. First thing that I would recommend that you do is notice there's a b value. So let's figure out the length of one period of this function. Okay. So My b value is 12 pi, so if I do 2 pi divided by 12 pi, what I get is that the length of one period in this function is going to be 1 over 6. Okay, so this is going to help us out here for when we draw the beginning. When we draw our function, we're going to have a beginning and an ending value for our period. If you want to, you can go ahead and mark the amplitude right off the bat. The amplitude is -5 here, which means the top value is going to be 5, the bottom value is going to be -5. Okay, and my period is going to start at 0, and it's going to end over here at 1/6, and we're cutting this into 4 equal parts. Okay, now the math here is going to be a little bit tricky because we're going to need to work with some fractions, but each piece of this function, I'm starting at 1/6, and I multiply that by 1/4. Each piece here is going to be 1 over 24. Okay, so this should be relatively easy, at least for the first piece, because I'm starting at 0 over 24. The next piece is going to be 1 over 24. The next piece is going to be 2 over 24, but this simplifies down to 1 over 12. Okay. The next piece is going to be 3 over 24, but that simplifies down to 1 over 8. And then the next piece is 4 over 24, but that simplifies down to 1/6. So if we count these out when we're done, we've got 0 over 24, 1 over 24, 2 over 24, 3 over 24, and 4 over 24, which makes sense because we're cutting these into 4 equal parts. Okay, now this is a negative sine curve, so just as we mentioned earlier, sine curves start in the middle, but if it's negative, the first place that we're going to go is down. So we're going to go down to the bottom, back to the middle, up to the top, back to the middle again. We will draw in a curve for the last piece of our graph. Okay, so there's the graph of this function. Okay. All right, one more, and then you guys will have a little practice for yourself to try for the remainder of the class period. So for this example, let's try this. This is going to be a little bit harder. Let's go y equals 3 times the cosine of 9/5 x. Okay. So let's start out by getting our amplitude on the graph here. Okay, our amplitude is 3, so this is going to go 3 and -3. And just so that you can see this, let's actually make this a negative cosine curve. Okay, so put a negative out on the front. Alright, let's find the length of our period. So our period is going to be 2 pi divided by, in this case, the b value is 9/5. Okay, if I do 2 pi times the reciprocal here, 5/9, I get that my period is going to have a length of 10 pi divided by 9. So I'm going to start here at 0, and I'm going to end at 10 pi over 9, and I'm cutting this into 4 equal pieces. Okay, let's figure out how much each piece is. So we're going to do 10 pi over 9 times 1/4. Okay, don't make your life more difficult than it needs to be here. 10 divided by 4 simplifies it down to 5 pi divided by 18. Okay, so each piece is going to be a 5 pi over 18 here. Right? So I'm going to start out. This is the same thing as 0 pi over 18. This is going to be 5 pi over 18. Okay. If I add another 5 pi over 18, that gives me 10 pi over 18. But this simplifies down to 5 pi over 9. Okay. So we've got 0 pi over 18, 5 pi over 18, 10 pi over 18. Another 5 pi over 18 is going to give me 15 pi over 18. But this also simplifies down to 5 pi over 6. Okay, so this is 15 pi over 18. If I add another 5 pi over 18, I get 20 pi over 18. But what you'll see is that simplifies down to 10 pi over 9. So when I'm done here, I've got 0 pi over 18, 5 pi over 18, 10 pi over 18, 15 pi over 18, and 20 pi over 18, which simplifies down to 10 pi over 9. Okay, last but not least, this is a negative cosine curve. Okay, cosine curves either start on the top or the bottom, but if it's negative, this is going to flip the parent function, which starts on the top, across the x-axis. So now it's going to start on the bottom. So we're going to start on the bottom, middle, top, middle, and then finish off on the bottom, drawing a curve here. Alright, And remember, we're always going to put arrows on the end to denote that this graph goes on and on forever and ever. Okay? Alright, there's sine and cosine.